So section 6.5, we're going to take a look at proving identities and kind of a little math humor over here to the right. So I think that's fine. Kind of funny. I don't know if you guys have ever seen Big Bang Theory or anything, but if you're bored and looking for something to watch, it's kind of a fun series to watch anyway. So what we're going to be doing is we're going to be proving trig identities. Now that word prove might scare you. We're not doing two-column proofs like we did in geometry, but we are trying to verify that the identities are equal to each other. So I'm going to give you some suggestions along the way, giving you some strategies to work with, but by all means, these strategies don't work every single time. It's just ones that you can kind of think of going to. So the first thing is you are now working with an equation rather than an expression like we were doing in the second section of this chapter. And so your goal is to get the left and the right hand side of the equation to look the same. So strategy number one is to take one side of the, take one side of the equation and make it look like the other one. And the suggestion is to have you start with the one that looks more complicated. So in this situation here, I'm going to use the left-hand side because it's got the parentheses, it's got a lot of trig expressions in it, so let's try and see if we can break that down. With the parentheses that are given to me there, I'm going to go ahead and I'm going to use my distributive property. So I have that sine of x times the cotangent of x plus, and then I have sine x times cosine x times tangent x. And now I'm going to try and simplify from there. Sorry, I don't know what I wrote. This should be cotangent here. Okay, I wrote it. All right. And so now what we can do is we can do a little simplifying it. What I like to personally do is when I see cotangents and when I see tangents, I like to rewrite those using sine and cosine. And so then I have sine of x times cotangent, so that's going to be cosine x over sine x. And then you've got your sine x and cosine x. And then tangent, you guys know, is sine x over cosine x. And so now with the multiplying of this and doing some simplifying, we've got a sine x here and one in the denominator, they're going to cancel. Here our cosine x's are going to cancel. And so now we're left with cosine x plus sine squared x, and sine x times sine x is sine squared x. Now take a look over here at what the right hand side is and notice that's cosine x plus sine squared x. So this is equal to that right hand side, and so we are all set. There's nothing else that needs to be done. Now with all of this here, you do need to just take it step by step to verify that these two are equal to each other. The fact that you are proving it to each other means that, yeah, they are equal to each other. You just have to show why they are equal. All right, let's try another one. Another strategy would be to, and you guys saw this when we were simplifying things, is when you're adding and subtracting to make sure you're always getting a common denominator. And a common denominator is as simple as looking at the two denominators and multiplying them. So I have 1 minus cosine x and 1 plus cosine x. So our common denominator is going to be those two factors multiplied together. So that means that I need to multiply the numerators out here. Let's see, minus. And I'm looking to, I mean, this seems to be like the more complicated side, so that's why I'm working with the left-hand side. So now my common denominator here is going to be 1 minus cosine x times 1 plus cosine x. Now, before I start multiplying this out, I'm going to leave it in factored form because you never know, you might have factors that cancel. All right, so I multiply this out here on the top, and we are going to get, one second. All right, so we're going to get 1 plus cosine x, since that's times 1, plus 1 minus cosine x. And so now when I look here, I've got cosine x and a negative cosine x. They're opposites of each other, so they're going to cancel. 1 plus 1 is 2. And now, since that's not going to cancel with either of those factors, I'm going to go ahead and multiply it out. So I get, they are opposite. They're the difference of two perfect cubes here, so I'm going to get 1 minus cosine squared x. Now, 1 minus cosine squared x, that's one of our Pythagorean identities. And so cosine squared plus sine squared is equal to 1. So 1 minus cosine squared x is equal to sine squared x. And we're getting really close to what we're trying to show over here on the right with the 2 cosecant squared x, because the reciprocal of sine, 1 over sine, I should say, is that cosecant. And so now you have 2 cosecant and that's what we are trying to verify over on the right-hand side. And so we're all set. So by combining, finding a common denominator, putting these fractions together, we used our Pythagorean identities, and we were able to get to that outcome. All right, then strategy number 3 is one that I've been using, and it's substituting one or more basic trig functions, and that's definitely working with your tangents, rewriting them as sine and cosine, using your Pythagorean identities or those reciprocal identities, trying to use those out. Especially if you know, like you're sitting there saying, I don't see anything that can be done. Now, one thing you want to always look for is whenever you see one of the trig values being squared, take a look at your Pythagorean identities. And so like here I have secant squared x minus tangent squared x. And when I look at that, that is one of those Pythagorean identities. And secant squared x minus tangent squared x is equal to positive 1. And so now I can rewrite this as 1 plus tangent x divided by the secant of x. So here you just put this in green so you can see where that came from. All right, and then if you look over to the right and what we're trying to get here, we're trying to get sine x plus cosine x. And notice that there's no fraction anymore. Well, here we can now break apart. This fraction is one way we could do this. So I can take 1 over the secant of x plus tangent x over the secant of x. And 1 over the secant of x, well, that is cosine x. So that's good news. Now when I look at the tangent of x, rewriting tangent x, I can do sine x over cosine x and divide that by the secant, which it might be easier for you to think of secant as 1 over cosine x. And now when I divide this out and I multiply by the reciprocal here, our cosine x's are going to cancel each other out. And that's going to leave us with the sine x. And so we will have cosine x plus sine x, which that is equal to sine x plus cosine x. All right, strategy number 4 is to look at the fact that sometimes you're going to want to factor to help you break things down, whereas like the first example, we FOILed it out. Here, you're going to want to sometimes factor. I can factor my numerator and denominator here. We can take out a 2 out of the numerator, and we're left with 1 minus sine x. In your denominator, we can factor out a cosine x, and you're left with 1 minus sine x. So what that has done here is it's taken out the GCF and helped us factor, and it's leaving us with factors of 1 minus sine x, which are going to cancel each other out. So now we have 2 over cosine x, and that is the reciprocal identity, and so we have 2 times the secant of x. That's what our goal is. All right, and then another one here. This one's a tricky one, and this is probably one that you would not have thought of to do, and that is multiplying an expression by an expression of positive 1. Now, when you multiply anything by 1, it stays itself. 5 times 1 is 5. X times 1 is x. And so you can multiply your numerator and denominator by the same value to help you out. And it's used a lot of times when you have a sum or difference in your denominator that cannot be rewritten. So here I have 1 minus sine x. Now, if that was 1 minus sine squared x, we could rewrite it as cosine squared x, but it's 1 minus a single sine x. So what I want to do here is I want to create that Pythagorean identity. So what I'm going to do, and you guys have done this with square roots, you guys have done this with imaginary numbers, and it's working with that conjugate. And so since I have 1 minus sine x, I'm going to multiply the numerator and denominator by 1 plus sine x. What this is going to do to our denominator is it's going to create the difference of two perfect squares, and it's going to allow us to use that Pythagorean identity. So I multiply this out. I'm going to, let's see, yeah, I'm going to want to FOIL it, so I'll go ahead and do that. So I'm going to get cosine x, actually, I'm going to leave it in factored form right now. So I'm going to get cosine x times 1 plus sine x. When we then work with your denominator and we FOIL this out, we end up with 1 minus sine squared x. We know sine squared x plus cosine squared x equals 1, so 1 minus sine squared x gives you cosine squared x. And now we're going to notice that there's a factor here that we can cancel out, leaving us with 1 plus sine x over cosine x. And then we can go ahead and we can break this apart. 1 over cosine, sine over cosine. And 1 over cosine, that is the secant of x. And sine x over cosine x is the tangent of x. And that is what we are trying to show, that equals the tangent of x plus the secant of x. All right, and then the last and final strategy that we're going to look at here is the possibility that you can work from both sides if you choose to. And sometimes that is a nice way to do it, especially if you get stuck on one side. Maybe you can start working from the other side. And that does mean that, like, you can use the addition property. You can add something to both sides. You can multiply, you can divide. We can do problems like that as well. So looking at this example, what I want you to try and do here is go ahead and try and pause the video and see if you can simplify any of this out. All right, the approach that I took to this problem, and you did not have to do the same thing. First of all, I took the cotangent squared x. I rewrote that as a cosecant of x minus 1. I worked from the right-hand side, and I multiplied out the cotangent of x. And then I did some simplifying from there. You do have the difference of two perfect squares in the numerator, and so you can factor that out in the cosecant x plus 1, cosecant x minus 1. Then that's going to cancel with that denominator. Over on the right-hand side, hopefully you can see how everything cancels out here. Whenever you take a reciprocal function and you multiply them together, you're always going to get 1. So cotangent x times tangent x, that's always going to give us 1. And then you can see that we get there towards the end. All right, so this last one here is one that if you'd like to try it, you can try it on your own. And I'll go ahead and pause the video and then I'll do it and see how you did. All right, so in this problem, I saw that I was subtracting two fractions, so I knew I was going to have to put those together. So I found a common denominator. You could do some factoring in this case as well. I distributed the cosine squared x's, saw they canceled out, and then I have a negative sine x cosine squared x and another one of those. So that's negative 2 sine x cosine squared x. Foiling out my denominator, I get 1 minus sine squared x, which is the same thing as cosine squared x. They're going to cancel, leaving me with negative 2 sine x. So hopefully you can see what's happening here. We're going to take 2 days on this once again, so please make sure that you're sending any questions my way if need be.